Hi students, welcome to my YouTube channel Lokesh Gupta Chemistry Classes. Today our topic is Solutions for JEE Mains 2020 January spell. Today I am going to give the solutions for the questions from group 1A, 2A, 3A and 4A group elements. See students, from these four groups together only they given 5 questions out of the 6 papers, 3 to 6 papers. 2 questions given from 1A group elements, alkali metals. 2 questions given from 2A group elements, alkaline earth metals. Only 1 question given from 3A group elements. No question given from 4th A group elements, carbon family. Now let me explain one by one. This question was given on 9th January afternoon. What is the question? Among the statements A to D, the correct one are. Here question is given on the anomalous behavior of lithium and diagonal relationship of lithium with the 2A group element magnesium. What is the first statement? Lithium has the highest hydration enthalpy among the alkali metals. So better to say lithium ion, small mistake. Now, what we know, hydration enthalpy, hydration energy is inversely proportional to size of the ion, cation and anion. If it is smaller in size, it can attract the water molecules strongly. So extent of hydration more. And hydration energy and extent of hydration directly proportional to charge of the ion also. Now, since lithium plus is the smallest among the 1A group ions, it has highest hydration enthalpy, correct only. Because of this reason only, some of the lithium compounds are hydrated salts. Next, come to the B statement. Lithium chloride is insoluble in pyridine. It is wrong statement. Why? Here, lithium salts have little bit covalent character. Lithium chloride is ionic with some covalent character. It has covalent character, so that's why it is soluble in organic solvent like pyridine. It is soluble. They said it is insoluble. So wrong statement. See, lithium chloride in some books they given as covalent compounds. That is wrong. Lithium chloride is ionic with some covalent character. How can we say it is ionic? Molten lithium chloride is good conductor of electricity. It is possible if it possesses ions only. If it is completely covalent, it is insoluble. If it is completely covalent, molten substance should be non-conductor of electricity. But molten lithium chloride, good conductor of electricity. So that's why lithium chloride ionic with some covalent character. Because of covalent character, it is soluble in pyridine, but they said insoluble, so wrong statement. Next, lithium cannot form ethynide upon reaction with ethine, means acetylene. It is the anomalous behavior of lithium. See, all 1A group elements can react with ethine or acetylene and forms ethynide plus hydrogen gas liberated except lithium. It is true for sodium, potassium, rubidium, cesium. So this statement also correct. So with acetylene, except lithium, remaining 1A group elements can react. Next, with the carbon, among the 1A group elements, only lithium can react directly. Remaining 1A group elements cannot react with the carbon directly. Next, both lithium and magnesium reacts slowly with water. This statement also correct. See, for 1A group elements and 2A group elements, down the group, reactivity with water decreases. Now, lithium reacts with water slowly only. Sodium reacts with water vigorously. Potassium reacts with water violently. Rubidium and cesium reacts with water explosively. Next, come to 2A group. Beryllium do not react with water or steam. Even at high temperature also reaction not possible. Magnesium do not react with cold water. but it will react with the water only at boiling condition. So magnesium less react with water only. Calcium, strontium, barium, they can react with cold water also. So lithium magnesium reacts with water slowly. It is a true statement only. So finally what is the answer? A, C and D only correct. Third option is the answer. Now come to the next question. On 7th January forenoon, the question is oxidation number of potassium in K2O, K2O2 and KO2 respectively is. See, in these compounds they want oxidation number of potassium, not the oxygen. So the easiest question. See, 1A group elements exhibits +1 oxidation number in their compounds, not in the elementary state. In the elementary state, 0 only. So 1A group elements exhibit only +1 oxidation number in their compounds. So in all these +1 oxidation number only. So second option is the correct answer. If they ask oxidation number of oxygen, see, in the oxides, oxidation number of oxygen -2. In the peroxides, -1. In superoxides, -1/2. In the ozonides, -1/3. How to identify that is monoxide or peroxide? In this case, that one easy only. See, potassium oxidation number we know +1. Sum of the oxidation numbers of all the atoms in a chemical species equal to charge. Now based on that, now oxygen oxidation number -2. So it is the monoxide, potassium monoxide. Now potassium +1. Now here oxygen -1. Oxygen -1. So it is potassium peroxide. Potassium +1. Total oxidation number should be 0. Here oxygen -1/2. So it is not potassium dioxide. It is the potassium superoxide. If you take KO3, it is not potassium trioxide. Here oxidation number of oxygen, you will get -1/3. So it is potassium ozonide. But here they want oxidation number of potassium only in all those compounds +1 only. Now come to the next question. This question was given on 8th January afternoon. The question is metal A on reaction with nitrogen gas gives compound B. Compound B. B on reaction with water gives a colorless gas, which when passed through copper sulfate aqueous solution gives dark blue violet colored solution. A and B are respectively. Now, we know that in 1A group, only lithium can react with nitrogen. Remaining 1A group elements cannot react with nitrogen. Only lithium reacts with nitrogen and forms lithium nitride. This is because of diagonal relationship of lithium with 2A group element magnesium. So 1A group element sodium has no reaction with nitrogen. All 2A group elements can react with nitrogen and forms nitride. Next, from 3A, boron, aluminum also reacts with nitrogen and forms nitride. See, when the nitrides are dropped into the water, then it undergoes hydrolysis and liberates pungent smelling colorless gas, ammonia gas. This ammonia gas, when passed through copper sulfate solution, you will get blue colored complex solution, deep blue color, cuprammonium sulfate. It is also called Switch's reagent, used in the manufacturing of artificial silk or rayon. So, sodium has no reaction with the nitrogen, so these two are not correct. Magnesium has reaction with the nitrogen. Then what is formed? Magnesium nitride, not magnesium nitrate. So, magnesium and magnesium nitride, it is the answer. Now see, an element burned in air or nitrogen gas. Then we got some ash. This ash dropped into the water. Then colorless pungent smelling gas, ammonia gas liberated. Now, if the solution left behind in the beaker is amphoteric, then what is that element? Beryllium or aluminium. Why? Because that nitride on hydrolysis, you will get hydroxide, na? Beryllium hydroxide, aluminum hydroxide are amphoteric. Next, when the ash dropped into the water, ammonia gas liberated. If that solution is acidic, what is that element? That element is boron. Why? Because boron nitride. On hydrolysis, you will get boric acid ammonia. Next, if that solution left behind in the test tube is basic, what is that element? Lithium or in 2A group except beryllium remaining 2A group elements. Like that, this concept is very important. Here our answer is magnesium and magnesium nitride. Now come to the next question. 8th January forenoon, the question is when gypsum heated to 393 Kelvin, it forms. What it will form? See, gypsum CaSO4 2H2O. When it is heated to 120 degrees centigrade, that is 373 Kelvin temperature, it loses 1.5 water molecule and forms plaster of Paris CaSO4 half H2O. Or you can write it as, if you multiply this one with 2 CaSO4 1 H2O. When it is heated to 200 degrees centigrade, that is 473 Kelvin, it loses that remaining half water molecule also and forms CaSO4. It is called dead bond plaster. Why it is like that? See, to this plaster of Paris, if you add water, it will again take 1.5 water molecule and it sets to hard mass. But to this, if you add water, it will not take water. So almost it died. So that's why, because of that reason only, they named it as dead bond plaster. If it is furtherly heated to 1200 degrees centigrade, then it decomposes to CaO, SO2 gas and O2 gas. Now in the question temperature is 393 Kelvin only, na? So plaster of Paris, option 1. Now come to the next question. This question given 9th January afternoon. The reaction of H3N3B3Cl3A with NaBH4 in tetrahydrofuran solvent gives inorganic benzene B. Further, the reaction of A with C leads to H3N3B3Ma3. Now, compound B and C. Compound B, this is B and C. What are B and C? It is the question. See, it is the B3N3H3Cl3. Those chlorines will be at boron, not at nitrogen. Why? Because it is formed when BCl3 heated with ammonia. It is formed when BCl3 heated with ammonia. So that's why chlorines will be at boron. Now this chlorine has negative charge. Now in the reaction with LiBH4, this Cl minus gets substituted with the nucleophile H minus. Then you will get B3N3H6. It is inorganic benzene. Why? Because its structure is similar to the structure of benzene. Next, it is also called boragine and it is also called triborine triamine. Why? Because you can write it as B3 NH2 taken thrice. NH2 taken thrice. So B3 triborine, NH2 taken thrice triamine. So these are the two names for inorganic benzene. Next, now here this compound is formed from this one. How? If you substitute Cl minus with Me minus, it is possible in the reaction with methyl magnesium bromide Grignard reagent. So now what is the answer? Boragine and methyl magnesium bromide. these are the solutions. Okay students, if you like my video, please subscribe my channel and click on the bell icon to get all my notifications. Okay, bye students. We will meet again with another new concept.